Okay, so hopefully you have filled out your table and you got these ordered pairs for these three. And then hopefully you graphed your ordered pairs. And then you found that what these make are these U-shaped graphs. These two open upward and this one opens down. And just trivia, the reason that these guys open upward is because our x squared terms are positive. And the reason that this one opens downward is because my x squared term is negative. These little guys are called parabolas. So all quadratic equations produce a graph called a parabola, spelled parabola, but pronounced parabola. So let's take a look at some things about this. I want to point out some things. Now below at the bottom, the vocabulary I'm going to talk about is right there, so you can refer to some of the vocabulary I'm talking about here, but I just want to look at these graphs for a second. One thing, if I was a really good artist and could graph these perfectly, these parabolas are symmetrical. And the thing, this one is really easy to see, the first one. The thing that cuts these two parabolas in half is called the axis of symmetry. So right here in this graph, the axis of symmetry is actually the y-axis. The graph of the equation of this would be x equals 0. So the axis of symmetry cuts a parabola in half. The point in which that parabola begins or hits the minimum point or the maximum point is called the vertex. So this one has these two have minimum points and these two have maximum points. These are called the vertex. Now the cool thing about these guys is that if you can get one side of the parabola, you can easily get the other side without having to get the ordered pairs. So if I got all the positive sides here, if you look, this point is the same distance away from the axis of symmetry as this point. And this point is the same distance away than this point, and so on. So, and that's true here. So this one, the vertex kind of comes off. There's not a straight line that goes here. There's going to be a little point right here. And the axis of symmetry here is going to be kind of through here. There is a way to find the axis of symmetry, which you're going to learn that in Algebra 2. These right here are the same distance away from the axis of symmetry. So right here, the vertex is where the axis of symmetry would go. So like this one, the axis of symmetry is going through x equals -1. And so these points are all 1 away from this, and then these 2 points are 2 away from the axis of symmetry. So now let's look at the bottom slide, and then I'm doing some stuff here, and then I choose to go the bottom, the vertex, and we've got an axis of symmetry. Now another cool thing to notice here are the x-intercepts. The x-intercepts, again, are the place where the graph hits the x-axis. What's super cool about the x-intercepts is the x-intercepts are the place where y is equal to 0. Now that's really important. So the next page, go ahead and flip it to the next page. Slide. Now the next page, you are given 3 sections. You are given graphs that have 2 solutions, you are given graphs that have 1 solution, and you're given graphs that have no solution. So do me a favor, turn off the video and write down what do all of these graphs have in common, what do all of the graphs in the middle have in common, and what do all of the graphs on the bottom have in common. Keep in mind that I said something about x-intercepts being important. So stop the video and do that. So what I was hoping you would notice here is that all of the graphs that have 2 solutions, like this parabola right here, hits the x-axis in 2 places. Same with this one. This parabola hits here, and then boom, it hits here. This parabola hits the x-axis here, and hits the x-axis here. So every one of these parabolas, if you trace them, hits the x-axis in 2 places. So something that has 2 solutions, they each have 2 x-intercepts. So these have 2 x-intercepts. And that's important. You may have noticed other things, but this is the main thing that I was hoping that you would pay attention to. Now the next slide, is that going to work? If you look at these are all graphs that have 1 solution. So look at this one, where all the vertices are. All of the vertices hit the x-axis. So these parabolas, like this parabola, only hits the x-axis once. This parabola hits the x-axis once. This one hits once, this one hits once, this one hits once. All of these parabolas hit once, and it is the vertex. So the x-intercept is the vertex. So these guys only have one solution, and these have one x-intercept. So that's important. The next one. All of these graphs never hit the x-axis at all. So if I graph a parabola and if it never hits the x-axis at all, these would be equations that have no solution. So if you have no solution, you have no x-intercepts. Now, why is this important? The reason this is important is because when you graph, so all of the graphs that you graphed at the very beginning started with y equals, like y equals x squared was one. I can't remember the other one was, but one could be y equals x squared minus 5x minus 4. I can't remember what the actual equation was. But the thing that is important is the value of x. When we're talking about x-intercepts are the value of x when y is equal to 0. So if I took this equation and I replaced the y with 0, what I have is the equation 0 equals x squared. And then I could solve that equation for x, and I would have the x-intercepts. Here, if I replace y with 0, I would have 0 equals x squared minus 5x minus 4, right? And you know how to solve this equation. So when we graph an equation, the place where the graph hits the x-axis are the solutions to the equation, because every single time we solve a quadratic equation, we set the equation equal to 0. Well, if I replace 0 with y, that's where you have the y-axis, where you have the x-intercepts, because that's the place where y is equal to 0. So now that brings us to a very important part. Flip it to the next page. So this guy up here at the top, this is all super important, and you will need to know these words. So the words x-intercepts, solutions, roots, or zeros, all of these words mean exactly the same thing whenever we're talking about quadratic equations. So when graphing a quadratic equation, it's another way to find its solution. Graphing is often used as a way to check your algebraic solutions. So all of the equations you solved before by factoring with the quadratic formula, if you set those equations equal to 0 and then you go to your graphing calculator and you go into y equals, you'll see that the solutions that you got are actually your x-intercepts. So super helpful. The x-intercepts on the graph correspond to the solutions of the equation, which I just said. They are often called roots or zeros of an equation. So when asked to find the roots or zeros, you are simply looking for the x values where your y value is equal to what? 0. 0 is what goes there. So if I give you a graph and I say, what are the roots or zeros of this particular graph right here? This is the equation. This is what the graph looks like. The zeros are here. 1, 0, 4, 0. Those are the roots, the zeros, the solutions, and the x-intercepts. All mean the same thing. So if I say, what are the zeros of these equations? You're going to give me the x-intercepts, and you can give them to me as just 1 and 4. This one, y equals x squared, well, the only x-intercept is right here at 0, 0. So the solution is 0. The root is 0. The zeros are 0, and the x-intercepts are 0, 0. This next one, if I ask you for the roots here, I'm looking for the x-intercepts. This and this. That point is -1 and +1. These are your solutions to the linear equation if I replace the f of x with 0. These are your solutions if I replace the y with 0, if I replace the y with 0. Solutions, roots, x-intercepts, zeros, they all mean the same darn thing whenever we're talking about quadratic equations. So, the next one is a little bit trickier. This is one where you would actually have to sort of estimate what the solutions are. So if you look, there's one right over here to the right, and there's one right here. So the first one is some number between 0 and 1. I would estimate that is probably something close to 1/2, right? And then the next one looks like it's between 7 and 8, probably something close to 7.5 or 7.5, or maybe even a little bit closer to 8, 7.6. I'm just going to go ahead and say 7.5. So this is an estimate that we just got from the graph. Later, at the end of this lesson, you're going to watch another video and you're going to learn how to find the x-intercepts of these using your graphing calculator. There's instructions and then there's also a little video you can watch. All right, let's move on. So when given a graph, you might get some of these questions like, how many solutions does this parabola have? Well, solutions correspond to the x-intercepts. So if you look at this graph, it has 1, 2 x-intercepts, which means that this parabola would have 2 solutions. And what are they? Well, they are -1 and 3. -1. That should say -1 and 3. So now, using my solutions, I want to write a possible equation that can be represented by this parabola. Now, the reason I'm saying possible is because whenever you write equations to parabolas, there are lots of factors to take in. Like, you need to know something about the axis of symmetry, you need to know something about how wide it is, how narrow it is. However, we could come up with some solutions that would give me -1 and 3 or an equation that would give me -1 and 3 as my x-intercept. So I want you to think back to when we were factoring. Remember when we were factoring, if I ended up with -1 and +3 as a solution, remember I had 2 factors, right? I had 2 factors where I resulted in getting -1 as an answer, and I resulted in giving +3 as an answer. So a very basic equation would be to start by coming up with your factors. So think about this. To get -1 as a solution, remember I had to undo operations. The very basic expression that would give you -1 would be x plus 1. And the very basic one that would give you 3 would be x minus 3. Remember when we were solving and it was equal to 0? Remember we took each of these, we set this equal to 0, we solved for x, and we would get -1. If we took this, we solved for x, we would add 3 to both sides, and we would get +3. So now, the reason I'm saying that this is a possible solution is because we could come up with many expressions when equal to 0, come up with -1, right? But all I'm asking for is the most basic one, all right? So what we're going to do, once you have the 2 factors, so these are 2 possible factors that would result in this as a solution, what we have now is we're just going to go through and do FOIL to get an equation. And we want the equation to be equal to y. So when I do FOIL, I'm going to do x times x is x squared. You're going to do x times -3 is -3x. I'm going to do 1 times x is x. I'm going to do 1 times -3 is -3. And I'm going to start this off with y equals. And then I'm just going to combine my like terms. So now my equation might look like this. Y equals x squared minus 2x minus 3. And this is a possible equation that would result in these as my x-intercepts or my zeros. Let's move on. All right, so the directions down here are asking you to write the solutions. Remember, solutions are just what the x-intercepts are. And then use the x-intercepts to give a possible equation to this. So start off by just your solutions. Your solutions are -3 and +1. So I'm going to have -3 and +1. And then we're going to start with the equation by starting it off with our factors, right? So I'm going to start off with y equals, and then I'm going to start off with my 2 factors, right? And so I'm going to say, instead of x minus 3, I'm going to say x plus 3, right? Because remember, if I'm solving this equation for 0, x plus 3 equals 0, I would have to subtract 3 to get -3. And then I want +1 as a solution, so I'm going to say x minus 1. Now, if you were to graph that on your calculator, it might not exactly look like this parabola, right? We're just thinking about x-intercepts, right? So later, when you get into Algebra 2, you'll learn how to get equations that are perfect. Right now, we're just kind of coming up with what could be possible factors that go with this. So now let's go ahead and do FOIL to make it look like a quadratic equation. So we're going to do x times x is x squared. So I'm going to get y equals x squared. And then x times negative 1 is negative x. And then 3 times x is 3x. And then 3 times negative 1 is negative 3. And then you're going to get y equals x squared. Combine those middle terms. That's going to give you positive 2x minus 3. And this is a quadratic equation that will result in those two zeros. All right, stop the video and try B completely on your own. And so this is what your answer is. The solutions, roots, zeros, are 2 and 4. And then the equation ends up being y equals x squared minus 6x plus 8. And the way that I got that, remember, I'm going to get x minus 2. If that were equal to 0, that's going to result in positive 2. X minus 4, if that were equal to 0, that's going to result in positive 4. So I just used those two factors. All right, now letter C, if you went ahead and started that one, you might get a little bit stuck. You have to remember there's only, whenever you have one x-intercept, so I only have one solution, the solution is 1. So remember way back when you were factoring, whenever we factored and we had one solution, we still had two factors, right? It's just that the two factors were the same. So we can't just say that the equation's y equals x minus 1, because x minus 1 is not a quadratic equation. We need two x's, right? So we have to have two x minus 1's, right? So that's going to make it quadratic. So you have to have two x's to make it quadratic. If I just have x minus 1, then I have a linear equation. And that's not going to work, right? Linear equations are straight lines, not parabolas. So now go ahead and do your FOIL. I get y equals x squared minus x plus 1. And then my middle terms combine to give me y equals x squared minus 2x minus 1. And there is your answer. All right, flip it to the next page. Try the next several. So the only real difference between these problems and the ones we just did is you don't have a graph. I'm just giving you the x-intercepts. So for this one, I'm saying that the x-intercepts are 5, 0, and 8, 0. So that means that the solutions are just 5 and 8, right? So my solutions are 5 and 8, right? Because that would be where the graph hits. The graph hits at 5, 0, and 8, 0, so those are your solutions. And then your factors here would be y equals x minus 5 times x minus 8. And then do FOIL here. I'm going to get y equals x squared minus 8x minus 5x plus 40. Combine your like terms, you get y equals x squared minus 13x plus 40. And so that would be your equation. These are your solutions, roots or zeros. Go ahead and stop the video and try B and C on your own. All right, again, letter B is one that just has one solution. It's 10, which means that both of your factors were exactly the same. They're both x minus 10. When you do FOIL, you do end up with y equals x squared minus 20x plus 100, and your solution was 10. All right, I haven't done the last one because I wanted to explain the last one. So the last one of your x-intercepts is 0, 0, and the other one is 7, which means you do have two x-intercepts. You have two solutions. They are 0 and 7. Now, if you think about that, this one, the factor that goes with 0 is just an x. You could say your factors are this. You could say your factors are x minus 0 or plus 0, it doesn't matter, and x minus 7. But I want you to think about that. X minus 0, we never factor something into x minus 0. Because what is x minus 0? Or what is x plus 0? It doesn't matter if it's minus or plus, because it's just an x, right? So this would be an equation where when we factored it, both terms had an x on it. So you have x as one of your factors and x minus 7 as the other factor. And then if I distribute here, I'm going to get y equals x squared minus 7x. And so that's what it is. And like if you look at that and I think about factoring that, they both have x in common. So you pull out the x, and that little x on the outside is one of your factors that is equal to 0, right? Okay, so the next little bit, I want you to tune into the next video, which shows you how to find zeros using your graphing calculator. So I'm doing two things. I'm giving you step-by-step instructions to follow, So if you want to just read through the instructions and see if you can pick it up that way, you can. Or you can tune into the video and the video shows you how to do it, and you can kind of do both. But what I want you to do with that is I want you to, as you're following the instructions, I want you to use that equation way back when we had to estimate what the zeros were, and I've listed the equation there. I want you to use that equation to help you find the exact zeros, or the estimated zeros even more, because when you have to do that, your zeros are going to be irrational numbers usually. So sometimes you have to use your graphing calculator to do it. Good luck.